Hi, in today's lesson we're going to look at something called simplifying radicals, or more specifically, simplifying square roots. So we just got done with our exponent lesson. So we saw that 1 squared means 1 times 1, which is 1. 2 squared means 2 times 2, which is 4, and so on. 3 squared is 9. 4 squared is 16. 5 squared is 25, and I'm just going to write the rest. And you should know the top, 10 of these, hopefully off the top of your head. But I'll go a little further. 11 squared, this one always gave me a hard time. You'd think it'd be 111, but it's 121. And 12 squared is 144. A square root is the inverse operation of squaring. So, for example, let's take this one for example. If 4 squared is 16, then the square root of 16 is going to be 4. So the square root essentially means what number times itself would give me the number underneath the square root sign. So there are many numbers that multiply to 16. 1 times 16, 2 times 8, but 4 times 4 is 16. That's why the square root of 16 is 4. So let's look at these first 4 examples. Number 1, the square root of the square root of 100. So if you look down here at our list, 10 squared is 100. So the square root of 100 is 10. By that same idea, the square root of 49, if we look at our list, is 7. And number 3 says the opposite of the square root of 64. Now I know the square root of 64 is 8, so the opposite of 8 is just negative 8. And then in number 4, we run into a little bit of a problem. The square root of negative 25. I know the square root of 25 would be 5, but 5 times 5 is positive 25, and negative 5 times negative 5 is also a positive 25. So we are going to say that the square root of a negative number does not exist. They did come up with something later called imaginary numbers because they did need solutions to these equations, but for all intents and purposes right now, we're going to say the square root of a negative number does not exist. Now, what about the square root of 24? Let's see, if I look at my list over here, 24 is nowhere on the right-hand side. It's somewhere between 16 and 25, so the square root would be between 4 and 5, but closer than 5. So we're going to look at a different way, to simplify this expression. We could put it in our calculator and say second square root of 24, and it would give me a decimal answer. So that does show me it's between 4 and 5, but closer to 5. But we want an exact answer, not that long decimal. So there's 2 ways to do this. I prefer the second way, but you can use either way you want. What you can do is you can do a factor tree, which you learned a while ago. 2 numbers that multiply to give me 24 are, 2 and 12. Now 2 is what we call a prime number because it's only 1 times 2. But 12 can be broken up into, 3 times 4. And 4 can be broken up into 2 times 2. So the square root of 24 is equivalent to 2 times 3 times 2 times 2. So I'm going to put all the 2's together, and I'll put the 3 in the back just to put them in order. Now, one way using a factor tree to simplify a radical is you have to look for a pair of 2 being multiplied by itself. Now here I have a 2 and a 2, so this would be equivalent to, take one of these 2's out, 2 times the square root of 2 times 3. Now this last 2 and the 3 did not have a partner, so I can just multiply them underneath the radical and get 2 times the square root of 6, or 2 root 6, some people say for short. So that would be a simplified version of the square root of 24. I do a different method. For the square root of 24, I simply look at my list of what we call perfect squares. The perfect squares are the numbers on the right. And I know that, let's see, 1 is obviously always a factor of a number. 4 is, 9 is not, 16 is not, and all these numbers are too big. So I prefer to rewrite 24 as 4 times 6. Now the reason this works is because I know the square root of 4 is 2. So this is 2 times the square root of 6, which I will write as 2 root 6. So I get the same answer 2 different ways. You can do it whichever you like. I'm going to do a couple more problems here, and then we'll get started on some practice. So I'm going to do these my method using the perfect squares. You can use either method you want. Let's see, the square root of 20. I know 20 is 4 times 5. And since I know the square root of 4 is 2, I can write a 2 on the outside and leave the 5 underneath the radical. So the square root of 20 is equivalent to 2 times the square root of 5. For my next example, let's see, 45. If I'm looking up here at my list, I know 9 is a factor of 45. So the square root of 45 is equivalent to the square root of 9 times 5. And I know the square root of 9 is 3. So this is 3 root 5. On number 7, they kind of throw a little curveball at you. There are no factors of 37 other than 1 and 37. So I can just leave it as that same thing and not simplify it at all, because 37 is what we call prime. Our last example, the square root of 75. I know 75 is 25 times 3, and I know the square root of 25 is 5. So I can write my answer as 5 times the square root of 3. Okay, so 2 methods. You can do the prime factorization, or you can just look for the greatest number in our list in blue. That's a factor of the number underneath the radical sign. Have a great day.